Welcome, everyone, to this late session. So this is Dr. Strangecode. The most important bit, though, is what stands underneath, which is how I learned to stop boring and love the type system. Just as a show of hand, like how many people have seen the actual movie, Dr. Strangelove? Good. I love it. I had to remove all the actual video reference and stuff to it in the thing, but there are still some quotes in there that come from the movie. So I started really enjoying type systems even more than I did before after I stopped doing Java for a living and went back to C and C++ and all of a sudden was remembered how much things can go wrong all the time and that we humans do one thing really good and it's doing mistakes. So I work at a company that's called Shopify in Canada. We're a big e-commerce platform, and we have a feature that enables our customers to run actual scripts, i.e. strings that come from the internet, and execute on our servers to power the business. Maybe some of you, so it's a big, the scripting language that we use is Ruby. That's what we give our customers to write code in. Maybe some of you know about a Ruby VM that's called mruby, for which there's been like a huge bug bounty payout last year somehow around $500,000 because of a couple of exploits in there. And yes, a bunch of that can be blamed on C and ultimately humans. So I guess I should start this where it all began, and that's in 1997 for me, when I was still young and good looking. And though I'm not sure about the good-looking part, a friend comes to me and tells me about like a new language is coming out from some company that looks somewhat like that. I knew them for the machines that they were building, UltraSpark, more precisely. And I was like, oh, that must be an awesome language. And so it was that language. And he explains like how cool it is and blah, blah, blah. And then he mentions something like it's being garbage collected. And I go, what? I'm writing C. I can manage memory. Like, what do you mean garbage collected? Nobody needs that. If you can't manage your memory, you probably shouldn't be writing code. But I wasn't really, I was actually writing stuff that I shouldn't mention. Disassembler for Nintendo 64, for those who know that game console. So effectively, long story short, I was a punk, like literally. I was actually playing music for a living. That's me on the floor there. So don't take any advice from me. What would I know, right? I wasn't a developer for real. I wasn't being paid 40 hours a week or whatever it is that we work to actually deliver code and add value to the business. So fast forward, probably 2001, 2002. So the guy that's biting his nail in the back on the right there, that's me, because I'm nervous. I'm writing code, and I need to figure out a way to do PDF generation like really fast, on demand for users. And all of a sudden, that memory comes back from Java. Hey, maybe we could do this in Java. So that's probably Servlet 2.3, Apache Tomcat 3, like nobody remembers that stuff. And I was crazy enough to even use JNI to actually use a thing that was called PDFlib, apparently still exists, to be able to generate those PDFs. And it turns out Java was actually fast enough for what we needed to do. And it came with no use after free problems. It came with no dangling pointers, no buffer overruns. Like all of a sudden, actually that managed environment I thought wasn't all that bad. It actually enabled me to get the job done and move forward. And so that's when my story, I guess, began with Java. And I've been writing Java for the next, I guess, 15 years or somewhat. And I moved to doing more stuff with Java. So when Tiger came out, that's Java 5, we got generics, we got a memory model that we could leverage. So I started doing more and more concurrency stuff on the JVM. Then moved on to a company that's called Terracotta that used to do clustered JVM, effectively clustered the Java memory model across big clusters. All that, doing bytecode manipulation. So I spent a bunch of my life on the JVM. But somehow things weren't quite right. I felt that, yes, what Java enabled me to do was really awesome, but somehow things not always went as well as one would have expected. Still, things kept on going wrong. So disclaimer, none of the problems you're going to see coming up next would actually happen. So that's a reference to the movie where they had to put that before the movie started because the US Air Force thought it was important that whatever this movie was depicting would never happen in real life. But what could possibly go wrong? So let's be all honest with each other. How many of you had to deal with a null pointer exception in, say, randomly the last week? Man, I saw a couple of events not going up. You guys were on vacation. That's awesome. So that's what the guy that actually came up with the null reference said about it in 2009. I think it was at InfoQ in an interview. It is interesting that I'm about quoting him on this. He said he couldn't resist the temptation to add it in because it was just so easy to do and implement, right? But initially the goal was to make sure that all use of references would be absolutely safe and check that compile time and nothing could ever go wrong. Well, we know how that went well. So I'm not going to spend more time on this. Null are an interesting case of things that keep on biting us. Another one that happens in Java, I think is kind of sad, is a switch case on an enum. So what is wrong with this code? Anyone? No default? Yeah. I said I was done with null, but it was a lie. I'm just a very bad guy. So yes, indeed, like at war in our class president isn't actually initialized, so that actually throws a null pointer exception. But you guys were right nonetheless, right? There is this issue with the default. Like, how do I make sure that all the enum instances for that type are actually covered by all the possible switch cases that exist, right? So let's fix the first problem first. So let's initialize this. For some reason, we had to add a new instance to this enum because you can be at war. Yes, you can be at war. No, you can be at war with the media. Apparently it happens. Somehow we had to add this instance. So we did. We initialized this block up there, and so now it's cool. We don't have a null pointer anymore. That's good. But that's what we get, right? So, and what should even the behavior be, right? If you're at war with the media and somebody asks you to go to war for real, what do you do? Like, do you throw the win the current one first exception, or do you actually let go of the non-so-important things and move on to the important stuff? So obviously you could write a test for that. You could write a test and make sure that that particular method does the right thing, but maybe there are other places that you don't know about where this new case has to be covered. Heinz Kabutz, who writes the Java Specialist newsletter in the it's the 161 something, has a way that you can actually sort of automate this and make sure that actually adds stuff and that there is something that covers all the cases. But again, I need to write a test for that, right? That's an example where looking at it, I feel that we should be in a place the compiler actually tells me that I forgot, most probably forgot something, and that I should just do the right thing. So locks. Who here writes concurrent code? Right. So nothing could ever go wrong with locks, right? All right, so now we have our class here. We want to leverage our precedent. And so we want to go to war, sadly enough. So what are we missing here? Well, let's solve everything with a lock, because when you have a concurrency problem, just add a lock. It'll be fine in the end. So we're going to use a lock. In this case, we're using a reentrant lock. That is mildly important to this example, but I'll show later why it is to some extent. So what we want to do is make sure that we lock, do go to war, do the proper thing, so that only one thread goes to war, and not all of them. That's good. And then we unlock, right? So as you guys saw, the issue is that obviously go to war can throw an exception. So again, what's wrong with this?
Try finally.
Try finally. You want to make sure that you release your lock. So the pattern is this one, because if the lock, if you wouldn't know what kind of lock it is, actually lock could throw. In the case of the reentrant, I don't think it ever does. But unlock can actually throw. So if you put the try, if you put the lock inside the try, be sure that you know what finally, like if you really need to unlock the lock or not, if locked through. I hope that made some sense. Because what could possibly go wrong? And again, that's again a case where I think that the compiler shouldn't let me do those things. So yes, again, I can run like static checking tools that will make sure that I don't do stupid stuff. But why isn't this directly built inside the compiler, or even better, inside the type system directly, so that that kind of things can't even be expressed? Bonus question, if we had like a way to actually see if we're at war or not, would this code be correct? Right, it's not safe because we're like, you should read and write using the same kind of happens before relationship. In this case, we're not providing any, so yeah, something's going to come out, but whatever. So that's not safe. And again, why can I do this? Why is it fine that I can express something that actually probably I never want to express? I don't know. This feels off. This one's iterator and validation. This one is a big one, certainly in C++. So anybody sees what the issue is with this code? So I'm creating a list, adding a couple numbers, and then I iterate over my list. If at some point the sum of the first elements in the list is 3, because that's very useful logic, then I want to add another element at the end of my list with the value 4.
Concurrent modification.
Exactly. So that actually would throw a concurrent modification exception, which actually just says that while iterating over the thing, I don't need multiple threads for that. So while iterating over the collection, actually I managed to change the underlying collection that the iterator iterates over, and that blows up. Again, why am I even allowed to do this? Why can't I, like, these are all things that I think were in Java, it's easy enough to shoot yourself in the foot. Like, how many people had the concurrent modification exception here? Right? And when the last time you had it, I guess most of you knew what you had done wrong, right? But you still, we're just humans. Another quote from Dr. Strangelove. But instead of the Dooms machine, we're talking about the compiler. I want something that's automated, that just knows what the right thing is to do at all times. And if I do things wrong, it lets me know and fix stuff. And since we're into quoting stuff, I think that we as developers need to find better tools to manage to express the right things and prove that our programs do the right stuff completely. And that needs to happen like as we program. One thing that I struggle with a lot, and maybe it's just because I'm old, but when I need to come back to code because, say, it's segfaulted, and it's really hard for me to put myself back into whatever the mindset I was in when I wrote that code. And that context switching is just annoying, certainly to me. So if I could get rid of this, I feel like I would be way more productive. Well, it does feel that getting to this is a task that could easily be accomplished by a computer. You need to say that with a very hard German accent. So let's look at an alternative language. So plan R is not for Robert, but for Rust. So Rust is a programming language that started in 2010. Actually started even before that, but really started, I think, appearing around 2010. 1.0 got released in May 2015. It's actually backed by Mozilla. That's what they used to build their new browser servo, or this backend to that. So let's look into what the code that we looked at right now, what it looks like now. So be warned, this is evangelism big time. I want you to rewrite everything in Rust, certainly if it's written in C. Everything has bugs in it. So Rust. Rust is a strong and static type language. It supports a thing called ownership and lifetimes that are built inside the type system itself. I'm not going to delve into lifetime in this presentation, but we're going to look at ownership and the kind of problems that it solves. In order to solve ownership properly, though, you need the lifetimes. It generally defaults to immutable. So when you do stuff, you need to be explicit when you want a value to be immutable. It does a whole lot of type inference. This type inference I find at times is both awesome, because who has ever complained about generic signatures becoming just way too horrible in Java? Right, so Rust, actually, if you want to be explicit, could probably beat it at it, but you don't need to do it. Interestingly, this comes with the downside that sometimes if you like thinking types, it's really hard for you to know really what is what. So you can always be explicit if you want to. Like JetBrains now officially supports like a Rust plugin for all their tools. So you can use it in IntelliJ, you can use it in CLion, which then also lets you debug the code, which is kind of nice. That actually has this nice feature where it can actually show you the types automatically, like all their intentions when you want to make it explicit or just know what it is. So that's really useful. Uses traits, so kind of your interfaces. And it comes with a very big ecosystem of a bunch of things. The most important one is probably Cargo. That is the build system. It's Rust's Maven, if you want. Does all the dependency management for you so that you can pull in libraries as need be. The one issue with it, though, well, it's not Cargo itself. It's more like knowing what libraries use nightlies versus the stable releases of Rust. So nightlies are the ones that are released nightly, where the platform and language, the core team effectively does experiments. If it makes it stable, it's going to be stable forever. But in nightlies, things change. So what's this ownership thing? So ownership is a way for you to know really who owns a binding, a reference to something. So let's say I have an instance of this bottle, and I own it, right? I created it, I own it. I can actually give it to someone, and then it's yours, and it's yours to keep. I just transferred the ownership of the bottle to you. I can also lend it to you, and I can do that in two ways. Either the immutable one, then I can actually like lend it to a bunch of people, but they can only look at how full the bottle is, like the color that it has, look at properties, like, but not mutate it. If I didn't lend it to anyone, I can then lend it to a single person, because obviously the two are exclusive, in a mutable way. So that, say, I lend you the bottle, you can drink out of it, you can write stuff on it if you feel like it, and eventually it'll get back to me. The important bit there is, again, the life cycle, because sometimes nobody owns the bottle anymore, and in Rust, like, it's totally predictable when the bottle will be destroyed. And that's, for instance, one way that in Rust, like the concurrent modification problem that we saw right before, is actually not expressible. You cannot write the code that will that would throw a concurrent modification exception, or worse. In C++, if you would add something, right, possibly the container, like the array that contains like all your element, could be moved to some other place in memory, and then, but your iterator already pointed to God knows where, and welcome to the jungle. All right, let's relook at what our code would look like if we would be writing our president in Rust. So I have the same enum up there. I have my public, so by default it's all private to my module. And I have the pub struct president that says, oh, it's a struct president, has this one field. So that's where like the initialization problem goes away. So I don't need, like in Kotlin, you don't need to specify new, because actually this will be allocated on the stack, not on the heap. So you don't write any new, you just create a new instance of this president. You see the type inference, right? Let president. I don't need to specify that it's a president. It's written right after the equal. And I have to initialize all the field. There is no way for me to not initialize a member of a struct. Like, I need to provide values for everything. So looking at our president, I am now implementing those two same methods that you saw before. So here are our methods. So the fn thing stands for function. Is at war, that returns a Boolean, and go to war, that returns a result of void, but possibly an error. Because Rust doesn't have any exceptions. So let's look at the first method. So the important bit is the ampersand, which says it takes a reference to self. Since we're implementing president right up there, it expects an instance of president to be passed in method to the function. It's effectively the same way that it works in C++. It's the only here at the method definition it's explicit. When on the call site, I can just write president dot is at war. I don't need to call a function and pass an instance in. That's the way it's declared. The important bit is, as I said before, by default everything is immutable. So in the case of the first method, it just takes a reference to self, to president. In the case of a second method, we actually need to pass a mutable reference to self, because as you see on the self.atWar equals yes, we're mutating the instance. An interesting bit is this has to be specified on both ends, i.e. both on the end that actually like consumes on the call, and as well as on the call side. So that it's always pretty clear. Well, I guess I have examples of that right after. So Rust added some sugar on top of things. The one difference that you see between the two methods there, like the one above, that line doesn't miss a semicolon at the end. If that semicolon isn't there, it's actually the return value that I'm specifying, which is effectively the same as, say, return blah, 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 and then semicolon, which is the return OK that you see underneath. So how do I see if going at war worked out or not? So you do that by doing pattern matching. That's what we do for the go to war. So let's see what the value is for at war. If we're not at war, we can just go to war. And if yes, we are at war, we just return the error. And that's where my compiler kicks in and actually tells me that the code that I'm expressing doesn't work because like it tells, well, the case where we're at war with the media, like that would ever happen, isn't covered. These are the kind of errors you get most of the time now with the Rust compiler. They try to be very explicit about what the error is and what you need to do. Sometimes there's actually an int that tells you, you probably forgot mute here. That's probably what you meant. Because that was like a big complaint in the early days where like the compiler errors, nobody really understood. So nobody knew what to do about them. So how would I fix this? So here I just decided that if you're at war with the media, I think you should first settle that, and then you'll try to go to war with somebody important. Maybe it's not a wise decision, I don't know. So I just added this case here with an OR and move on. But so any call site that would have had a pattern matching against all those instances of my enum like would have been called by the compiler. So that's how you would invoke that go to war method. So it's the same line, instantiation line as before, and then present go to war. And that doesn't compile because the go to war method took a mutable reference to a president, which is not what we declared on line 4. So it's actually telling me, consider changing this to mute president, saying that I want a mutable instance of that. So defaults to immutable always. So just doing that, and we're good to go. We can go to war. That's awesome. I see there is a bug in the slides. Well, let's do it with that. Markdown for the win. Okay, so we're going back. If we wanted to write now the same code as we did before, but like thread safe, the way that you express that in so let me see where things went wrong. I guess these are supposed to be 2 slides. So we just add a mutex in this case. So I create a new mutex. That's a static function u on mutex, which I didn't do for the president, but is considered as a constructor. And I pass in the president. This is called interior mutability, because effectively what I do is I transfer the ownership of my president to the mutex. So that if I would write the code that you see under this title, president mutex transfer the ownership of the president to my mutex, and then try to go to war directly with the president, this will tell me this, that I did move the value of president there, and I'm trying to use it afterwards. And I can't do this. Which avoids the kind of problems that we saw before that, it's what was the annotation again? Guarded by, to just say like what is guarded. In this case, it's not like best intention or whatever, right? The type system just makes sure you transfer the ownership of whatever it is you're trying to protect. In this case, with this mutex, it could have been a read-write lock, like this bunch of other primitives, but I just went for the simple one. It doesn't work. And the way that I would then do this is I would call lock on mutex, which returns AP. And this is where it's really nice to have type inference, because actually what's being returned is this. So it's a result where, in the case where everything went fine, I have a mutex guard that guards the president. And in case things went wrong, I have a poison error that actually contains the mutex guard for that president nonetheless, so that I can get back to my resource. But what it's trying to tell me is that this lock was poisoned. I'll get back to that, what poison means, in a second. So if I would to use that P, I just put that in a scope there for a second. So that's resource acquisition is initialization that maybe some of you know from C++. So this guard, I can explicitly get to the guard by calling unwrap. Let's say I know there is something inside that lock, right? I get to it. And and then on that guard, I call go to, so the unwrap like returns me the guard, and I can, the president, I can go to war. But the first trick is releasing the lock. So when the guard goes out of scope at the end of this curly brace here, it automatically unlocks the lock. So I cannot forget to unlock the lock. The one thing that can go wrong is actually this. So if I go to war, actually I wrote that wrong. No, I wrote that right, sorry. If I go to war and I call unwrap on the result of that method, before I didn't check whether I managed to go to war properly or not. If I call unwrap here, what's going to happen, that's going to panic, because what I return is a failure from my go to war method, because I already was at war with the media. I couldn't go to war with some random country. So that will panic, and as such, the mutex will be marked as poisoned, because things went wrong while holding the lock that protects the resource. So that's concurrency quickly in Rust. So it comes with other stuff. Well, I guess the important stuff is to remember that the data belongs to a single owner. You push that in your read-write lock or whatever. You can have multiple readers, that's fine. Single writer nonetheless. So there are other types that you can compose where this is where the signatures, if you're being really explicit, are going to become like explicit. So you have arc, which are automatically reference counted, which helps to know when to get rid of the resource that somebody protects in case you're sharing it across multiple threads. You have the mutex that you just saw. And then there's this thing like this trait that's called send that defines how you can transfer ownership of things from, let's say, one thread to another. So one other thing that I can show quickly, I think, is a little bit of assembly code. There are other kind of nice stuff that that Rust does, which is, for instance, this method. So we're on godbowl.org. If you don't know that website, I think you should bookmark it. It doesn't support Java, though. That's sad. So, but it supports Go, Rust, C++, obviously, and a bunch of compilers for all of those. So what's wrong with this code? Yes, it overflows. So if I compile this, actually you will see, so you can look at the color stuff. So the yellow matches the num times num matches the yellow on the, so line 4 to 9. And the interesting bit is actually that so line 6, the set OAL, actually checks if the flag that we overflowed doing the multiplication on line 5 was set, which meant we overflow. If we did, it's actually going to do a jump to, where is the panic method on the call? Anyways, you get the attempt to multiply with overflow thing. The interesting bit is this one is that's the default behavior of the compiler, which the default compiler is actually the debug mode. If I would to actually ask it to compile stuff in optimized mode, we get rid of that. Like nobody checks nothing anymore. So you can run your tests and verify that at least that doesn't happen if you need to deal with it. But if you optimize stuff like that, check goes away. It's all LLVM based, and some people on Crete were crazy enough to try to port all the intermediate representation of that LLVM code to Graal and Sulong, just as an exercise. We got two things working, so it's interesting. Who knows? And maybe we get Rust on the on Graal soon enough. What the world we live in. All right. Moving on. And So discovering Rust actually to me was kind of an eye-opener that there are actually ways to get to better safety. And that was interesting, and then I got more interested in all that stuff. And it turns out there's a bunch of very interesting efforts going on that are, let's say, non-neglectable. So I'm going to talk a bit about another language, and that's Pony. I don't have that much experience with Pony, to be honest, but like the things that they tried to do and the stuff that I played with, I found pretty awesome. And they have goals apparently for supporting a distributed actor model in a very safe way that looks very, very promising. That's on their roadmap. So if they ever get there, it looks like it could be solving a problem that I've been fighting way too much in my life. Because having type mismatch in big clusters is just a nightmare. So Pony. Again, type safe, object-oriented, as an actor model as a way of doing anything. So concurrency, obviously, but if you would want to do like a single-threaded thing, there would be one actor doing it. It's memory safe. Sorry. Exception safe, i.e. let's be sure that there is no runtime exception thrown ever, and everything is handled properly and tells us about it at compile time. No data races, no deadlocks. No deadlocks because there are no locks. So when there are no locks, it's hard to deadlock. But nonetheless, make sure that you get the proper visibility. One big difference is that it's actually a garbage collected language or runtime. There has been a presentation at Splash 2 or 3 weeks ago in Vancouver. If it comes online, or I think the paper should come out about the ArcRGC, I guess I would recommend, well, maybe like nerds have a look at it. But it's looks like they're on to interesting stuff. One important bit is that they have a mathematical proof for everything that they put in the language. So until those proofs are correct, everything they pretend is also true, and that's pretty awesome. So the way that they actually managed to deliver on those promises is capabilities, and capabilities come in two ways. There are object capabilities and reference capabilities. I'll show quickly a couple of reference capabilities. So object capabilities are the way for you to allow things to be done with your objects, while reference capabilities are ways for you to specify things not to be done with the references, i.e. those memory locations. Like for instance, here's a thing, you can't write to it, you can't read to it. Seems kind of weird, but it's actually supported. And so here's an example of this. ISO would sort of be like the equivalent in Rust to make sure that there's no alias to the same thing. So here I'm trying to create an alias from A to B on the second line there. That is something that I cannot do because ISO stands for isolated, I guess isolated or isolation. And so it's a reference, but that cannot be aliased. So tag is actually, that's what I just said. So in this case, I'm creating an alias B, but it's tag. I cannot read and I cannot write from that B. But I can store it and I can, for instance, use it for comparison. So that can be useful. But I cannot use whatever is at that memory reference. One thing you can do is consume, the equivalent of transferring, well, the equivalent, kind of what we saw with transferring in Rust. In this case, like the first line, that's allowed because the second line is, so the second function line. So first one says consume A into B, which means that A now is invalid anymore. I cannot use A. So this line that was previously invalid with adding the consume is now fine. But then the C, which is a tag reference to A, that's not valid anymore because A isn't valid anymore. Another thing that's interesting and kind of confusing at first is the way that that Pony does exceptions. So exception is like if you would only ever throw like a single static thing. So in case that isn't clear, that's kind of what this matches to. So this code, it's not the way you would write this code, not in Java, not in Pony. It's just to illustrate the control flow. So you have your try that does exactly what you think. Error says throw, else says catch, and then does the equivalent of finally in Java. But if you look at this, there is one thing that really sticks out, is that you just error. You don't throw anything. And you just else. You just catch. You don't catch anything. It just is the exceptional path. There aren't types that, instances of types that you catch. It's like if in C++ you would decide to throw, I don't know, like 1 all the time and catch that. All right. So I think that it's like this quote somewhat resonates with me a lot. I find that we need to take way more away from us making sure that we actually write correct code and that the compiler can take care of this, and that we should focus on whatever it is that we're actually trying to solve as a problem by writing this code. And I think anything that helps us getting there is good for, I like to hope, everyone. That means certainly probably our employers, but most probably also the consumers of whatever it is that we deliver to people. So that's a quote from the Humble Programmer that was written in 1972. And one thing that I would like to see, my goal is effectively this, right? If it compiles, just ship it. If you wrote the code the code and the test that prove that whatever it is that you actually need to do, the test should only test like the logic, the business, whatever thing that it is that you do. And if it does compile, that you can be sure that this code is bug-free and can be shipped. I know there is another session, hopefully in the future, I didn't check, but Elm actually is kind of the same approach, right? Trying to make sure that whatever it is that you build actually will not throw any runtime exceptions in production later down the path. And I think that's very important for a couple of reasons. So here comes the one sales pitch for me. So I work, as I said, at Shopify. We actually, the mission statement is to make commerce better for everyone. It's a company that was founded in Canada in 2006. We currently have merchants in over 170 countries in the world, 2,000 plus employees, 2,000 plus apps that people can use, 500,000 merchants using our stuff. But the important thing isn't that. It's the way that, well, it is important because it gets my salary paid, so it is actually important. Don't quote me on this. The important thing is that we actually release probably around 40 to 60 times a day during a working day. Code changes all the time. And I think we need to put things in place so that we can have that, we invested a whole lot of time in this infrastructure so that this could happen, so that people can be confident enough to ship code at a very high pace. I think that's important. Whatever it takes to get there, I think makes our life better. And I think that type systems is one way of achieving that. Funnily enough, we are actually an entirely Ruby shop, so no types there, or at least not checked statically. But we manage nonetheless. So if you think that could be interesting, I think we should chat, because we're hiring. And you're all smart people, and so we're hiring smart people, so we already have one match. But that's it. Thank you. Try to stay safe. If there are any questions, I'd love to take them. There are 6 minutes left. Any questions? Okay, I guess that's no questions. Thanks a lot. Well, if there are further questions later, just grab me and we can talk. And if you look for a job, talk to me too. Thank you.